Roger, Mudfossil University, on the cutting edge of Higgs boson country. Composed of neutrinos? Who knows? Well, let's find out. Alright, this is from Cornell University Library. They're talking about the Higgs field, which is the field created when a particle called a boson travels through space and induces a magnetic field around itself. The particle is called the charge carrier, and the field is the Higgs field. So it goes by the name of the Higgs boson. Now, they call that a neutrino. Now, let's go see what a neutrino looks like. And I have done light research, and I believe I've captured all of the things that they're talking about, and I'm going to try to prove my case. So let's just move forward. Alright, this is what they claim to be the signature of an electron neutrino, is the electron shower, and it is Cherenkov radiation, which I'm going to explain in a moment, which is always produced from a accelerated particle coming into a deceleration, and that creates Cherenkov radiation from the electron shower produced by electron neutrino event. Produces multiple cones and therefore diffusing ring in a detector array. Now let's see if we can fulfill that requirement. Just so you understand where I'm going with this, these I believe are the Higgs fields, and the little particle charge carrier that is being accelerated creates this field as it decelerates and creates Cherenkov radiation, which is the neutrino field, and I will show you how I have arrived at all this. And you see all these little dots? Those little dots are the polarized ether particles, which do exist, which are nothing more than free electrons, and they polarize to create that pattern of plus minus plus minus plus minus with, I believe it's with other molecules of some sort, probably water molecules in the air. But I can't guarantee that's true. All I can tell you is that there is some form of plus minus, and there are Fibonacci patterns, it looks like. They stay away from each other in an exact orientation that they're the furthest away but the closest they can get. That's the nature of quantum. And all of these fall into that pattern, and that one there is extremely energetic compared to the rest, and it crashed into one of these disks and released a semi-disk, a tiny one of these disks. So we're dealing with scale, we're dealing with energy, we're dealing with fields, we're dealing with particles, we're dealing with acceleration, we're dealing with Cherenkov radiation, we're dealing with quantum. The whole 9 yards is here, and I will describe every single bit of it. And I'll tell you all the things that are needed for me to prove that this is Higgs boson or neutrinos, however you want to look at it. So let's look at what a neutrino is. Alright, the way Cherenkov radiation happens is a particle is accelerated faster than the medium that it's coming into. And it's a high-speed particle, and which is the electrons that we've accelerated. Now, these are in a nuclear reactor, and these are nuclear particles, too, apparently. Or they might be just extreme amounts of electrons. I don't know, because there is no neutrons. So it has to be either protons or electrons in enormous quantities. And I believe it's, well, let me put it this way. I'm going to say it's electrons in enormous quantities. Now, they can call it anything they want, but I'm saying these are electrons in enormous quantities, and the water cannot accept them quick enough, so it literally crashes into them, creating this Cherenkov radiation. And exactly the same thing that we created with the Venturi, because the Venturi restricts the amount of light that can enter it, but it's forcing itself, so it crashes and creates the Cherenkov radiation in extreme magnetic fields because of the energy. And anytime you have an increase in energy, it increases the magnetic fields. And that's what happens. And I will display this, all of the experiments that we did that show that this is a fact. Okay, this is the writer of the Pauli principle, which I won't go into, but here's what his statement is on neutrinos. And he's talking about primarily, well, actually, no, he's talking about electron neutrinos. He said that they, on December 4th, 1930, Pauli wrote a letter to Physical Institute of the Federal Institute of Technology, Zurich, in which he proposed the electron neutrino as a potential solution to solve the problem of the continuous beta decay spectrum. An excerpt of the letter reads, "Dear radioactive ladies and gentlemen," he goes on to say that as the bearer of these lines will explain more exactly, considering the false statistics of N14 and lithium-6 nuclei, as well as the continuous beta spectrum, I have hit upon a desperate remedy to save the exchange theorem of statistics and energy theorem. Namely, there is and remember this now, to save the exchange theorem of statistics and the energy theorem. Here's the problem. They're all working with Einsteinian nonsense, really. I'm telling you, it's nonsense. And I'm sorry to say that, but nobody will go against them, so I'm going to go against them. Everything with the atomic model is wrong based on wrong assumptions. So I'm not even going to bother to go on there. But he has a Pauli exclusion principle and so forth. And he's got some points that aren't completely wrong, but not completely right either. But anyway, he's the one that was talking about the electron neutrino, and he says, look, it says it's the same mass. So the mass of the neutron must be of the same order of magnitude as the electron mass. No, it isn't. They're nowhere near each other. It's 1,800 times difference. Neutrons, well, what they call a neutron, 1,800 times the size of an electron. Now, I'm going to go against all of that shortly, but let me go and show you why I say we have seen what they are talking about, if this is actually truly an electron neutrino. All right, what would I have to do to prove electron neutrinos? And to prove that I can show that they exist and that we have photographed them. Let's see. How can an electron neutrino be proven? Well, you would have to first of all show that a particle could be accelerated, because that's what happens. They're accelerated particles that crash into other lower or more dense media or whatever to make them become slowed down. That's what happens now. So you would also have to show Cherenkov radiation, which is that real glowy white chaos, which you show they have it in the nuclear reactors to slow down the particles in the water, and that's what the Cherenkov shows. It's a very glowy white, not natural white, very, very high energy white. And so you'd have to show that glowy white chaos at that impact where it came from the accelerated point to the non-accelerated point. And you see it in the exactly that happening in nuclear reactors. So we need to show that. Now, I would also need to show impact shower cones with the fields, which I showed how they come out in a cone at the point of impact. Then I would need to show that the charge carrier, which I'm calling an electron, they call a neutrino, which is a negative particle, but it's not. If it's negative, it's not carrying a charge. How's it going to create a field, a Higgs field? So there's a problem with that in their way of thinking. So anyway, I say it's a charged particle and the charge carrier, and that charge carrier is truly an electron, which creates a field around it. I would have to show that. And I would have to explain the quantum effects that we're seeing. So the step down of radiation would come with a quantum effect, I would think, after it entered unrestricted space. All right, so let's go and view the experiments that I have done along with Rod Warren in Australia on light through a Venturi. And Rod discovered, well, he sent me these pictures and I realized what he was doing, and it's in a Venturi. And it accelerates the light, and that's why we see the effects that he has in these pictures. I'm going to try to make this extremely simple, and then we will go over the details that relate to some of these dots and things like that. But what we're seeing is a pulse red laser which is coming through the air, creating a literal shock wave almost identical to a sonic boom of a jet through the air. And that is just strictly unrestricted. It's coming through the air, and it is polarizing these things in the air, creating these polarized charged particles. It's an induced charge. Okay, remember I said that you needed to be able to accelerate light. So you saw that wave I showed you a moment ago. Now it's becoming compressed as it is being drawn through a Venturi. And a Venturi is two cylindrical steel drums, and the light has to force itself through that restriction. Because of that, there is no option whatsoever. It must accelerate. Light is performing identically to a liquid. This is the liquid as it is being compressed through a Venturi, which is nothing more than like a nozzle on a hose, or the old carburetors in car engines had this identical setup. The gas entered, and as it hit the restriction, it atomized and spit out the other side in an atomized blast like this. All right, so what do we see here? We see that white, as I said, Cherenkov radiation, which is in the nuclear reactors. It's the same glowy, extreme chaotic white. We see the compression of the wave, and I mean, I don't see how anybody could say that not accelerating. We know that white is a higher energy than red, so we know that it's increased in energy, and that is the result of being forced to crush against each other. These electrons are coming down, and I'm saying these are electrons. Light is electrons. That's my statement. The electrons come in, and as they are forced to get into each other's regions, they will not allow that. And they become very chaotic and forceful against each other, and that creates energy, and they start buzzing. And literally, Rod said he could hear them actually literally buzzing as they come through this Venturi case. I don't think every time, but and he did a lot of experiments. Now, the other thing you want to notice is these reverse waves. Remember, it comes this way, wave, 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 in a circle this way. Well, this is a reverse wave, and that is because of the extreme energetic reaction at the Venturi. Now, so what do we have? We have the wave coming through, just happy and going along by itself. Then it becomes restricted, compressed, drawn into a restricted zone, accelerated, which we need. That's one of the requirements, because we need to come down back into the space we are in now, which will make it decelerate because it's no longer restricted. So it goes through that restriction, it comes back out and steps down in a quantum. To me, I see that. You see, it comes out of here spraying like crazy, and it steps down to what I would say was pretty much of a quantum distance. It comes from here to here, and it backs off here to here, and then it starts creating this enormous backfield. And it re-radiates the plates reverse, because we're going to see these coming on this side as they reform themselves. Now, what else do we see? You see these particle beams here? Pretty well established, you see them? What happens is, as that light comes down, hold on, let me get my prop here. The actual truth of the way light is entering this restrictor here, which is the Venturi, is the light is coming this way. We see it as these curved shock waves coming through the air, but it's really a particle that is coming through the air. Now, we see the wave around it, and I believe it does spin to some degree in a restricted spin, because I have seen that in a shot, and I'll show you that in a second. They do spin. I have to remember to show you the blue spinning tubes. I'll remember that. I guarantee I'll remember that. I'll probably forget it. Now, anyway, it turns into this beam. It comes in here, bada boom. It steps down to here in a quantum. It shoots out all this, because what happens is as it spins, if it comes, the particle is here over the top, it shoots it out this way. If it comes in through here, it shoots it out this way, coming down through the bottom. If it's halfway between, it shoots it out in the middle, and most of it is blurring into a line in the middle, and that is the pattern you see against the wall in every single single slit, double slit experiment. They make these different patterns. They say, oh, it's because the waves of electromagnetic nothingness. Well, it's electrons is what it is. Now, just to finish up, just this one single picture shows, I'm saying that's accelerated. If you could say that's not accelerated, I don't know what else I can say to you. I'm seeing white. Cherenkov is this white radiation. If you don't see the white, I can't say what I can say to you. It's increased in energy. If you understand how energy works and how high the spectrum is on this, I don't know what else I can say to you. If you can't see it stepping down in a quantum, which is the other requirement as coming out, in my mind, I'm just saying, I would say it would step down in a quantum, but it doesn't necessarily require that. And then you see it spray as it starts to reform. Now, we're going to be looking down at what happens right at this point here and how it starts to turn yellow and then back into its red particles. Alright, that's your restrictor right there. That's your Venturi. And as it comes out, they're literally in chaos. They are beating each other up. Get out of my way, get out of my way, you get out of my way. Yeah, you get out of my way. I love to talk to the molecules. Now, so they're fighting each other. They're fighting like hell. There's all kinds of heat and plasma and interchange of fields are just crushed against each other, trying to get through that restrictor. Now, as they come out of here, they say, whoa, whoa, thank God, let me loose here. So they start opening up. They start turning yellow. They start turning red. They start reforming into these normal original discs that we saw. Now, you see some of them are crossing each other's paths up and down here. They will bang into each other and cause what I'm going to show you will be an extremely strange event and something that is throwing a big wrench in the little wrench, which is the monkey wrench. Alright, let's go see what we got. Alright, remember I said it's got one of these little disky looking well, it's a light spins like this. If you showed this to a machinist, he'd say, yeah, somebody just turned a drill bit and it goes right in there. The light is coming in and it's dipping behind this side, and if it doesn't get dipped behind, it comes over the top and it dips behind again. That's how you get this pattern here. Alright, and so you can see the boom, 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 boom. This is where it comes through. That's the center. That's just the way it works. And you see this in all the slit experiments. Alright, I think I showed this at the beginning, but now we're back to looking into the Venturi coming at us. And it's hard to see, but you can see these are the things that make the patterns on the wall in the back, that circular pattern I showed a few minutes ago. Now, what are they doing? They're particles coming out of here. And what are these things? Those, I believe, are what they refer to as the Higgs field. And it's a field surrounding the boson particle. And these, I know these are coming through here as particles because I can literally see them. You know, you can't tell me these are waves. In my mind, these are particles. I know they're particles anyway because they hit things, they move things, they push solar sails, they push electrons in solar panels. They're not a nothingness. They are a particle, and that particle is an electron, which is a negative monopole going through the air, spinning through the air at a certain speed so fast that this field surrounds it. This is literally electricity in the air. Light is electricity in the air, and that is a magnetic field that surrounds it. And if you put a wire up through here, and the wire had magnetic filings around it, it would create the same thing. They would line up plus to minus, plus to minus, plus to minus, just like this, right around that wire. It's identical. Alright, so what do we have here? Coming out of the accelerator, Cherenkov radiation. Again, stepping down from extreme acceleration, like in a nuclear reactor, to the unrestricted space, creating the rainbow shower of neutrinos. That's what I see. That's what I see. Every single thing that I have shown explains identical to what they require to be these electron neutrinos displaying Cherenkov radiation and the particle showers. I don't see where I'm missing anything. Now, it's not hard to recreate. Very, very simple. So, and now, the thing that I told you about the monkey wrench part, well, there's a little monkey right there. Now, you see this trail coming out of there? Zip. Very compact, very bright. That is a high energy, high speed apparently, because it catches up to and impacts with one of these and creates a mini disk. These are light particles. In my mind, every one of these is a light particle. Some of them go a little faster. They have a different violet color, orange color, red color. And there's these different colors. They're not all going the same speed. And that little sucker is going a zillion miles an hour. So it's going to bash into one of these. And I'll show you what happens. And it's spectacular. All right, there's the discs. They're coming all together. However, this one comes through. That's the white one I was talking about. You see how it has already, it's got a built-in field that's just tight or something. I don't know how to explain it. I really don't. But I do see what I see, and you can see what I see. We know these particles all came out of here, and we saw a zillion of them, so they're all pretty much the same, except this one. In this particular shot, there's other times it happens too. Now, but not often. Now, it obviously has caught up and impacted with this field. It has its own field. It hits this field. When it hit this field, it seems to have created its own field similar to this field. And it starts stepping down, and it shot off a particle similar to this, only tiny. That's what I see. Now, you see exactly what I see. So, if these are Higgs fields, and these are boson particles, what the hell is that? You know, I mean, the rabbit hole goes very, very deep. Like, this is, there's a lot here. And, you know, and now, here's my point. Here's my point. I've shown a lot here that any scientist, any physicist, anybody that looks at what I just showed would say, well, the guy's got what he's got. It's what it is. Right, I have to look at it. I got to check this out. Why should I just turn my heads away? And you know what will happen is the first things out of their mouth will be, well, where's your degree? Where'd you go to school? I got enough schooling to go cover all this stuff, so don't worry about that. I did actual work, my friends. So this is what, you know, if I was illiterate and I showed you this, what's the difference? Don't attack me for that kind of stuff. That's ridiculous. This is the problem. You want everybody to come and pay you to become a thinker exactly the way you think, of your own opinions, and disregard the reality of the world. I'm not going to go with it. All right, so I think I have proven my point. You show me I'm wrong. Okay, here's a couple things just to prove what I was saying. You see how these are actual light particles. That's my claim. I can't be certain, but I am saying, before I told you that I would have to show you the actual accelerated particle. Here it is. It's obviously accelerated because you see how it's starting to compact. It's not staying the same distance. It's compacted up here, so it's accelerating, decelerating. I'm sorry. This is where the accelerator has a zoom. Now, what about, why is this thing drifting? This little white dot drifting to the left. I believe that is the charged particle, and I'll show you what it looks like in our pictures. Very strange looking. It looks like the old atomic symbol, and it's drifting to the left. That means the tube is turning to the right. The particle is spinning to the right, which is the right-hand rule, and it's exactly what is expected. Nothing here is not expected, but you got to get away from Einstein. All right, I don't know if you remember, but the red wave just went through here, and you could see no difference between here. There was no bump in the middle. This, I believe, Rod did in through glass. And what it does is it creates a bump around the particle path. And of course, there's all this radiation comes around it, these little things. Those aren't just little nothings. Those are literally ionized particles, you would have to call them, plasma particles, shock wave particles, however you want to think about it. And I'll show you why I'm saying that. What you just saw before is exactly the same phenomena, but in a different medium, in the light range. This is breaking through from the sound barrier into another realm, and it's just crushing everything that's in front of it away from it, creating this shock wave and that enormous boom. I mean, I don't know how to make it any clearer than that. It's a shock wave. It's a shock wave. That's what it is. It's exactly what we're doing. See the bullet? Well, we're going through the air with it's creating a more flat plate, more of this nature, because it's just going so much faster. And you can see this gets supersonicer. It's my own word. It's flattening out more of that wave. The slower the movement, the more angle to the wave. It's just, and this one here is almost flat. It's just the nature of the acceleration. You see it? So, you know, that's all I can say. Ooh, I almost forgot. These are the electrons. Particles, I don't know what they are, but I'm calling them electrons. And they have what looks to me like some kind of a torus form. You see? That indicates to me the white is energetic and the black is not energetic. The spike coming down is also black on this side, white on this side, white on this side, black on this side. You see that? Now, what does that mean? To me, I'm seeing some kind of a shaking effect, an AC, like there's a neck in here of the torus, and as the the energy, and I can't explain this, I obviously can't, but as something's going on in there, to me, I can see energy and no energy. That's all I'm going to tell you. And then I see this spike, so it's something is flipping like that inside there, to my mind, and the neck is the restriction. It creates inductance, and it causes inductive reactance, which opposes the incoming current up to 10 times. It forces it back into the cavity, which creates capacitance. So you have inductive capacitance, inductive capacitance. It's back and forth, something like that. I don't know. Now, over here is the chaotic white coming out of the accelerator. He's just all blurby and blobby. Get away from me. Get out. Get out. You get out. Okay, so they keep coming across here fighting with each other. Now, you see you got white, black, white. Now, this is interesting. Now, then you go into this, and they do this little blippy thing. Then you go into black, white, black. You see? White, and it's, you can see the energy stepping down. It gets dimmer and dimmer as it goes across. So anyway, that's just what I'm seeing, and you can make up, well, you can see a zip. That is the nature of the step down of the interaction between a restricted airspace, causing the electrons to become into a plasma mode, forcing them to accelerate, and then crashing into non-restricted airspace, stepping down into quantum I showed. Now let's just finish up, and then I'll leave it at that. Hold on one second. All right, I think somewhere along the line I started out asking this question: how can electron neutrinos be proven? Well, first of all, you have to show accelerated particles, and I think I showed that, accelerated light particles. They weren't neutrons and nuclear particles. They were light coming out of a red laser. So I think I showed that. We accelerated them through that Venturi. I show glowy white chaos at the impact zone where these electron neutrinos crash into they're accelerated and they have to come back down in speed. That's what creates this thing, and sure enough we see this at the exact impact site. Now, show impact shower cones with fields. I did show that, and the fields have little dots all around them, which are polarized particles created by the charge carrier particle, which they call something like that a boson. I don't know if that's true or not, but the field around it, they call something like that a Higgs field. and seems to fulfill all those requirements. So I'm showing that. I guess that's what it is. So I'm going to show, then I show the charge carrier, which is the electron. Actually, I'm showing that, the charge carrier. I actually show the electron, that little red electron. I mean, it's a particle. I don't know what it is, but it seems to be the one that creates the field. I showed actually the tubes, and I showed the electron spinning in the right-hand spin, which is what they claim it should do. I showed the field's compacting so that it obviously is slowing down. I explained the quantum effects of seeing where the light steps down in that white, and then it steps down to the orange, and then it steps down to the red, and so forth. I don't know. If somebody have any more requirements, I mean, I could try to fulfill them, but I don't think I can think of anything more. So I think we got what they're asking for. So, and I've presented this to a lot of places. At MIT, I've presented it to Harvard and Stanford and all these places. I never got any response, and the ones I did talk to said, "Oh, it could be anything." And I said, "Well, please explain this." And I don't have to explain it. You have to read our books. I said, "Okay." Which is everything that I've ever said to any of these people. That's the response I get. They're not interested in looking at anything that might upset their apple cart. That's my statement. Could be wrong, but that's my experience. So if you can come up with a different explanation for all the things I showed that are exactly what they asked for, it's exactly what they asked for. If I'm missing something, tell me. But some physicists, please, take a notice of this. Ask me what I'm doing wrong. I said, tell me what I'm doing wrong. I know it's going, oh, it's glare, it's this, it's that. Where do you go to school? Where's your doctorate degree? And everything. I don't need any of that stuff. I'm showing you something that you cannot ignore, so please don't ignore it. You're wasting all your time looking for things that aren't even real. That's a fact. I'm just going to tell you the facts. So if you want to ignore it, you're going to ignore it. So I might as well just tell it as it is. These are facts that you shouldn't ignore. Let me put it that way. Okay. This is Mudfossil University. Have a sterling afternoon.